Math 113, Lesson 5.4 is trig functions of real numbers, and then we're also going to talk about periodic functions. Probably one of the most important things that we're going to talk about when it comes to trig is the unit circle. So you may have heard about the unit circle before today, and here's what the unit circle really means. Okay, it means that its radius is 1. Pardon my lovely circle there. So these points right here are all on my unit circle. Okay? So this is what it means to be a unit circle. X squared plus y squared is equal to 1 because r is the radius and the radius of this circle is 1. So let's just make sure we write that down. So r is 1. If I draw myself let's say we just pick a point right here, and we can say this is an angle. We're going to name it, instead of naming it theta, we're going to name it angle T. Okay? The radius of this circle is 1. Now I've marked that using the quadrants, the ordered pairs, but if you actually see it written here, you know R is 1. Okay? And then we also talked about earlier in chapter 5 is that the length of this is called S. Right? So let's just relate that to what we're doing here. S was R times theta. All right, well, we've just decided that in this problem, R is 1, and we're calling theta T. So S is T. 1 times T is T. And what we need to think of is T is the radian measure of the central angle. Okay, it is a central angle. All that means is the vertex is at the center. And our central angle that we usually work with, we usually call it theta. And we're just saying we're calling it T. It's just a different notation that my math lab uses. So I wanted to explain where that even comes from. So we've got this point right here on our circle. And for now, let's just call that point XY. Okay, we were doing that in section 3. We had a point on the terminal side. We called it XY. Well, since this is the unit circle, all right, we're going to think a little differently. We're going to think of X as cosine of T. Cosine of theta, think of it that way. And we're going to think of Y as the sine of T. So really this is the ordered pair, cosine T, sine T. That would be our ordered pair. And so now let's talk about trig on the unit circle. Now we did some trig in section 3 where we had sine was y over r, cosine was x over r, and so this is very similar to that. We just are using the idea now that we know that r is actually 1. So in section 3, we said that the sine of theta was y over r. Well, in the unit circle, we know that r has a value of 1. So really all we're saying is that the sine of t is y, but this is the reason for that. Okay, I just wanted you to understand why it was happening. The cosine of t is x. The tangent of t, remember t is just theta in radians, okay, the central angle. Y over x, that hasn't changed. The cosecant of t is 1 over y. The secant of t, 1 over x. And the cotangent of t is x over y. These really are not different from what we did in section 3, except we know now that the r value is 1. Okay, so we're just putting 1 everywhere we used to have an r value. I don't want you to feel like it's something entirely different. It's not. All right, let's find the values of the trig functions at t. Now an old question would have said the trig function's at theta. Well, today we're using t. Now I'm going to give you a diagram. Okay, this is what you would be given. You'd be given some sort of diagram that looks like this. My math lab will have it already drawn and it will look way better than my hand-drawn one. Okay, I know for sure that this ordered pair is 1, 0. That proves to me that this is the unit circle. I've got a point on the terminal side of my angle theta, in this case is t. And that point is the square root of 3 over 2 and 1/2. That's my point. Looks a little different. It will also explain to you, you know what, this is the unit circle. It's just trying to prove to you that this is definitely the unit circle. So if we're going to do all 6 trig functions, we're going to use what I just showed you. We learned that the sine of t on the unit circle is just the y value of that ordered pair. So it's 1/2. The cosine of t is x. So the x value of that point P is square root of 3 over 2. And then tangent of t would be the y value, in this case is 1/2, divided by the x value. Okay, you cannot leave a fraction in a fraction. So let's simplify that. Okay, dividing by the square root of 3 over 2 is the same thing as, flip that second fraction over, change it to multiply by the reciprocal. So 2 over the square root of 3. So my 2's divide out, and that leaves me with 1 over the square root of 3, which I cannot leave. Okay, let me keep going with tangent of t down here. So I've got 1 over the square root of 3. I must rationalize. So I get the square root of 3 over 3. So that's our tangent value. It did ask us for all the trig functions. Okay, it said the trig functions. There are 6 of them. So we do need to do all 6 of them. All right, cosecant of t. Remember, it is the reciprocal of the sine. So it's just 2. The secant of t is the reciprocal of the cosine. So 2 over the square root of 3, we must rationalize. So we get 2 on the square root of 3 over 3. And then our cotangent of t, okay, I've got to do the reciprocal of tangent. Now I'm going to show you the easiest place to do that is not the original. Okay, we ended up here, 1 over the square root of 3, and then we had to rationalize. So if I just flip that one over, I get the square root of 3. So the reciprocal is just square root of 3. So there we are. Those are our trig functions. Okay, section 4 is much shorter. So we got another type of problem that we're already ready to be able to solve. So let's do a different one. The directions are still the same. Find the value of the trig functions at, but this time it says t is equal to pi. All right, find the value of the trig functions at t is equal to pi. All right, so the diagram will already be drawn for you. Okay, it will already be drawn. However, that's something you need to be really paying attention to because eventually you'll have to draw it yourself. All right, now pi would be starting at the x-axis, going all the way over to here. Okay, so there's my t, which is my radians, pi. The point that they're giving you this time is right here. The point is -1, 0. Now, also have this other point labeled 1, 0, and it is likely going to have this. These 2 pieces of information just proves to me that this is a unit circle. All right, so we are going to do the sine, cosine, tangent, cosecant, secant, and cotangent of pi. Okay, again, this is not something we're typing in our calculator. Okay, we're using the unit circle to help us out. So the sine of pi is the y value of that p ordered pair. So the y value is 0. The cosine of pi is the x value of that ordered pair p, which is -1. The tangent of pi is the y value over the x value, which ends up being 0. I don't know if things are disappearing on when you see this, but it keeps going away, so sorry about that. Seems to be a little glitch. All right, the cosecant of pi, like one of my legs of pi just disappeared, but it's going to come back. So, not sure what's going on there. Okay, so the cosecant of pi, we have to do the reciprocal of the sign. Well, that would be 1 over 0, which guess what? That is undefined. You cannot have 0 in the denominator. Okay, that's a pi. All right, the secant of pi is the reciprocal of cosine. So 1 over -1 is just -1. Make sure you simplify. And then the cotangent of pi, it is the reciprocal of tangent, so -1 over 0, which again is undefined. You can't have 0 in the denominator. All right. Next idea is domain and range. I know that's something that some of you really love and some of you really hate. It's really not too bad with our trig. All right, so domain, and let's just focus on sine and cosine right now. Okay, the domain of sine and cosine, okay, those two functions, is always -infinity to infinity. It includes all numbers. Okay, the domain, theta can be anything, is what that's saying. Okay, theta can be anything, for sine and cosine. The range, however, that is not true. The range for sine and cosine, think about it like this. On that unit circle, the y values, it stops at -1 to 1. I know you're thinking, well, so does the x. But we can keep going around the circle. So that's what changes that for us. So the domain and range, this is them always for sine and cosine. Even in odd functions, we studied those in Math 112. All right, so even trig functions, there are 2 of them. Remember, to decide if a function is even, we plug in negative to whatever the function is. So in this case, t. So -t, and when I do that, I get positive, which means it's an even function. It means cosine is always an even function. The secant, when you plug in a -t, you end up with positive secant. So it is an even function. Which means all of the rest of them are odd functions. So sine is an odd function. Here's what that means. When I plug in -t for sine, the positive and negative changes out front. It becomes a negative sine of t. The cosecant of -t becomes negative cosecant of t. The tangent of -t is negative tangent of t. And then the cotangent of -t is negative cotangent t. Again, this is something that you are going to want to keep handy close by when you're working problems so that you can refer back to it. Chances are it's going to take you a bit to memorize some of these things, so have it handy, have it beside you so that you can refer back to it. All right, let me show you how we're going to use that. If I say find the exact value, remember, that's no calculator, okay? When it says exact value, do not pull out that calculator. The cosine of -60 degrees. Okay, well, I just told you that cosine is an even function. So the cosine of -60 is really just the cosine of whatever 60 is. And the cosine of 60, if we use the little table, or if we use the hand trick, the cosine of 60 is 1/2. Okay, let's try another one. Let's do the tangent of -pi/6. Okay, well, tangent is an odd function, so that would be negative times the tangent of pi over 6. So I'm going to put a negative out in front of my answer. And pi over 6, okay, that is a 30-degree angle. If I do the hand trick, or if I look at that little table, I get negative 1 over the square root of 3. I must rationalize. Hopefully you're understanding how your calculator is not going to help you come up with these answers. All right. One last little idea for section 4. I told you we would talk about periodic functions. Now, here's what it means to be periodic. It means the function begins to repeat itself. All right. At some point, the values begin to repeat themselves. That's what it means to be periodic. It begins to repeat itself. All right, so mathematically, this is what that looks like. A function is considered a periodic function if you can take that function and you can add some radian measure to the theta that you already have, t, and the value that you get out is exactly the same as before you added it. Right? So let me make sure we understand here. So with p as a positive number, okay, p is just some positive number, okay, and we want the smallest such p is the period of our function. Okay, it's the period of our function. Whatever that smallest p is the period of our function. Now, you don't have to do this, but let me just explain what I'm talking about. If I took sine and I graphed it out on an x and y axis, stretched out, not on the unit circle, this is what it would look like. Kept going. That's what it would look like. So here's what I mean by periodic, and it does keep going forever. It continues this direction and it continues this direction. So this would be the sine function stretched out. All right. You do not have to know how to graph this. I'm just trying to show you what it means to be periodic. So right here, the sine has a value of 1, a y value of 1. Okay. Well, guess what happens? After I go all the way, let me do a different color, okay? I'm going to trace it along. Okay, after I go this far, guess what? It repeats itself. And guess what? It's going to continue to do that. So it's going to revisit that same value over and over and over and over. And so the p value that I'm telling you right here, p is how far it is from right there to right there. That's what p is. How far before it repeats itself. Now, you do not have to know how to stretch this out, so I'm going to erase it because you do not have to know how to stretch that out. Just wanted to give you some sort of visual. Okay, so for sine, we've got some theta. If we add 2 pi, we end up at the same value like that one value I just showed you. So the period is 2 pi. Okay, because our p value is 2 pi. So our period is 2 pi. For cosine, guess what? It's the same thing. So that's good news. So the period of a cosine function is also 2 pi. All right, tangent is different. Tangent, when we add pi, we end up repeating ourselves. So for tangent, the period is pi. And so the reciprocals would go along with them, right? So let me show you how we would apply that information. So this is our last set of examples. Again, our directions are find the exact value. So calculator's not going to do me any good. All right, so let's start with the cosine of 405 degrees. All right, now if we tried to do reference angles, that's really kind of what we're working with here, but we're going to use this idea right here. If I have the cosine of 405, let's think about it like this. What number plus 360 gives me 405? Because 2 pi is 360. So 45 plus 360 gives me 205, right? So we're going to actually do what is the cosine of 45, all right? Very similar to reference angles. What is the cosine of 45? Well, the cosine of 45 using our table or using our little hand trick. The cosine of 45 is the square root of 2 over 2. Pay attention to what quadrant cosine is in. I'm sorry, what quadrant 405 is in. 405 is in quadrant 1, and that's where everything is positive. So I can confidently say the cosine of 405 degrees is positive square root of 2 over 2. Not the decimal that your calculator would give you if you typed it in. All right, let's do the sine of 7 pi over 3. Okay, so what plus 2 pi gives me 7 pi over 3? Well, I need to think of this as 6 pi over 3, because then I have to have the same denominator. Oh, 1 pi over 3 plus 6 pi over 3 gives me 7 pi over 3. Okay, so what is the sine at pi over 3? Using my table or my hand trick, that would be the square root of 3 over 2. Your calculator will not give you that. Now let's think about it for a minute. What quadrant is 7 pi over 3 in? It is in quadrant 1. All right, so it's going to be positive. So the sine of 7 pi over 3 is exactly the same as the sine of pi over 3. Remember, periodic, it repeats after so often. So the sine of 405, the cosine of 405 is the same as cosine of 45. In fact, it's the exact same spot. Same thing with pi over 3 and 7 pi over 3. That's actually the exact same spot. We would call those coterminal angles if we graph them individually. All right, so you're going to need to practice, practice, practice. If you've got questions, please visit our Teams meeting that we have. I can go over problems. I can work them right there with us seeing each other and talking live. Otherwise, you are certainly welcome to email me with any questions that you may have. Have a great day.